Wow, everything looks completely different from this chair. It's like
You're on a
I
new
can-
side.
I can see why you like this chair though. This chair is really comfortable.
Well, we heard that they didn't like your penmanship, Bill, so I'm going to try to help out here.
All right. You take it. You take a chair. You go ahead and look at chapter 8.
All right, class, now that you're in Chapter 8, some of you might remember there are 2 F words in mathematics. Bill, do you remember those 2 F words?
The first word I'm sure is fraction.
Fractions. Students, they hear fractions, they run. Matter of fact, they've been running since middle school from fractions, haven't they?
That's right.
What's the second F word, Bill?
I would guess you're thinking probably factor.
I think factoring is it for this course. Now, we're going to try to simplify it today for them.
That's right. A lot of you have probably been taught factoring by the trial and error method, which I know that a lot of you probably find difficult. So Jerry and I hope that we're going to make this a lot easier for you, and so that by the end of this chapter, you will have a bit more confidence in your ability to factor. I don't think we can emphasize enough how important factoring is. It's something you need to be able to do in intermediate algebra, you need to be able to do it in college algebra, and even if you go above that. When I teach students in Calc 1 or Calc 2, I still need them to be able to factor. It's some of the best spent time you can have, taking the time to learn how to factor.
Outside of fishing.
Yes, that's
Outside
right,
fishing.
yes, outside of
Okay.
fishing. Or maybe barbecue.
Well, let's go ahead and get started, Bill. First rule in factoring, this is the number 1 rule. If students forget it, you're always going to run into trouble, and that is the common factor rule, which we're going to always allude to as Rule 1. Looking at this problem here, when you see this, the first thing you want to do is think, is there something common that I can take out of both of these terms? In this situation, there is. There is a 5 that we can take out of both terms. So what I'm going to do for this first problem is put a 5 underneath each one. That's just signifying, hey, I can take it out. Now I'm going to divide, just like we did in the last chapter that Bill was teaching. All right, when I take out a 5, what am I left with? Well, the first thing in parentheses is going to be an x. Why? Because 5 times x gives me 5x, which is the first term. The second number is going to be a 4. And hence, that problem is now finished. It has been factored. 5 times parentheses x plus 4 equals 5x plus 20.
That's right. Remember that you can always check your answer to a factoring problem very easily. Just multiply the pieces of your answer together. If you end up with what you started with, then you didn't make a mistake.
Absolutely. All right, let's look at the second one. Bill, this sometimes gives students a lot of trouble. When you look at these 2 terms, and we're trying to find a common factor in both of these, what do you see that's common in both?
Well, I notice that there are x's in both places and y's in both places. So the question I'm asking myself is which power of x and which power of y can I factor out? And the answer to that question is when you're factoring, you're looking for the smaller of the 2 exponents. That's what you can factor out. If both terms or all 3 terms all have the same exponent, then you can factor that exponent out. So in particular, what number could I factor out here? Why don't we let them think for that for a second and then tell us what the answer is. We'll wait a little while. We need that Jeopardy music.
We really do.
We really do.
Okay. Well, if you guessed that 3 was the largest number you could take out, that is correct. And then with regards to your x's and y's, you can take out an x, y from each term, because that is the smallest power of the common variables that you have. So what does this leave us with? Well, you put the 3xy on the outside of the parenthesis, and then inside the parenthesis, you ask yourself, 3xy times what gives me 6x squared y? Start with the numbers, you get a 2, and then an x. Going to the second term, just carry the sign over, the minus. 3xy times 3y will give us 9xy squared. And that problem is now finished. One thing to always remember to check is when you look inside this parenthesis, if you still see a number that can be taken out or a variable that's common in both terms, you need to go a little bit further. You need to do it again.
That's right. So it's always worth looking at your answer and making sure there's still not something else that can be factored. This will particularly be important when the problems get a little longer, or in particular when the numbers get a little bit bigger.
Yes. Okay, this last one. A lot of you that recall your Algebra 2 days in high school, you would probably jump at this problem with that trial and error method you were alluding to. and you would make this problem twice as hard. The first step, remember the first rule, every time it says factor is to look. Is there something common in all three of these terms? In this situation there is. There's a 2. So we're going to divide each of those terms by a 2, which means we're going to put our 2 on the outside, and then our first term is going to be 2x squared. Then our second term is going to be 4x. And then, is the last one 0, or do we just cut it off
No,
here?
remember that 2 divided by 2 is still 1.
Yeah. God, that first grade math we keep forgetting. Don't we see that all the time?
That's right, yeah. It's a very common mistake.
Okay, let's move on to a couple more difficult questions in this area.
All right.
Okay, now, working on the grouping method. First of all, we cannot forget Rule 1, can we, Bill?
No, you still have to look and make sure there's not a common factor you can factor out first.
Right, so we're going to look at this problem. We look at the x cubed, the x squared, the x, and then we have a number 20. So we notice, first of all, we don't have x's in all of them. Then we look at our numbers, and clearly we don't have numbers we can divide in all of them. So basically, we cannot use Rule 1 on this problem. So this is kind of like Rule 2. When you see 4 terms, and put this on a note card, when you see 4 terms, think about grouping the first 2 and the last 2 terms together. The reason why we do this is for this reason. Out of the first 2 terms, we see that there is something common. There is an x squared that I can take out. Now, I'm not going to write the x squared underneath. I think by now you're getting a little comfortable with this. But you pull the x squared out, and what is left? What would go in the parentheses? Well, Bill, what would we put in here?
Well, to get x cubed, I'd have to multiply x squared by x.
Absolutely.
And to get negative 5x squared, I'd have to multiply x squared by negative 5.
Perfect. All right, so that's our first term. Now we look at our second term. We say, what is common in both of those? Well, I see a 4. You see anything else?
I think all we can pull out is a 4 because there's not an x in both places.
That's right. So we put our 4, and amazingly what happens? What happens in the second
Well,
parentheses?
to get 4x, I'd have to multiply 4 by x. And to get negative 20, I'd have to multiply 4 by negative 5. And this is where the grouping method comes in. Now something wonderful happens.
Yes, here's the wonderful part. You now end up with 2 binomials that are identical. Now, I want you to look at this as one term, and this is one term, and this is where students lose it right here, isn't it?
That's right. Think of the x minus 5 as if it was a single piece.
Yes, and we're going to draw that single piece over here. Let's replace x minus 5 with a y. So we have x squared y plus 4y. Identical format to this, but we replaced x minus 5 with y. Well, now that you've learned Rule 1 in factoring, you know that there is a y in common over here. Now, please, don't confuse this with our other problem. This is just a sidebar, okay? We take the y out, and what is left?
Well, there's an x squared left in the first term.
That's right.
And there's a plus 4 left in the second term, so that would be y times x squared plus 4. And now we're going to try to do exactly the same thing with our original problem.
That's it. We have 2x minus 5s. When we take them out, 2 become 1. And I know I can draw a better 5 than that. So we have the x minus 5. So in other words, just like over here, you see 2 y's, but when you factor it out, you end up with 1. Same principle happens here. We see 2x minus 5s. We're going to take 1 out, so we only see 1 now. And then in the other parenthesis, all we're going to do is put that x squared plus 4. In other words, the stuff that was on the outside, let's see if I can get a different color for everybody here. This right there makes up your second parenthesis all the time.
So in essence, the thing to remember is the thing that you wrote twice is the first part of the answer. The 2 leftover pieces, the pieces that Jerry's underlined in blue, are the second part of the answer. As long as you can get from that second step to that third step, that's the key idea of the grouping method.
Absolutely. Now, this next problem very much resembles an exit test question. You notice we don't have any numbers, just a bunch of variables. Principle is still the same. All right, step 1, shift colors again. Green, blue, red, eventually I'll find it. There we are. Group the first 2 and the last 2. This one has a little trick to it, doesn't it, though?
That's right. Notice that Jerry included the negative sign to the left of the CX inside the parentheses. If there's a plus sign between the second and third term, it doesn't really matter whether or not you include it inside the parentheses. But if there's a negative sign between the second and third term, make sure you include it inside that second group of parentheses.
Couldn't have said it better myself. So here we go. We're back to rule 1. Just look at this parenthesis. We have an a that is common. And what's left? X minus y. Again, a times x is ax. A times y is ay. In the second one, we are going to pull out a negative c, just as Bill said, when it's negative. You'll notice if we do it that way, negative c times positive x is negative cx, and negative c times positive y.
Yeah, there's a typo in this problem.
We
Unfortunately,
have a
we have
cotton-picking
we have a
typo.
problem. Yeah, we're stuck.
How did we do this?
I saw this coming.
Okay, now, when you see this, this was not intentional, but when you see this, it brings up a great point. I cannot go any further on this problem because these are not like terms. If these aren't like terms, you're finished. As a matter of fact, you go back to square one and say, that is my final answer.
In other words, that problem actually can't be factored, at least not using the grouping method.
That's right. Okay, now, let's look at how this problem was supposed to be written here. Let's change this last sign to a plus sign. Okay? Now, just as we started before, grouping the first two and the last two again together. Out of the first two, we can take out an a, and that leaves us with x minus y. And out of the second two, I can still take out that negative c. And again, watching my signs, negative c times positive x gives me negative cx. And then my second sign, negative c times negative y, gives me the positive cy. Now you'll notice this time both of our binomials match. So now we can go to the final step, which is take out the x minus y. What's remaining on the outside? A minus c.
That's right. Take out the common term and then put the other two pieces in the second parenthesis. It's really that easy. Again, let's emphasize, anytime you see 4 terms, chances are 99% of the time this is going to be how you factor it. You factor it using the grouping method. So that's how to recognize one of these problems.
And the other 1% are teachers' mistakes.
That's right.
Simply put.
Which you'll occasionally see.
That's right. Okay, let's move on. Okay, now we've left the 4-term polynomials. Now we're going to look at the trinomials, which is what most students remember from their algebra days.
Yeah, if you remember any factoring from high school, chances are these are the problems you're thinking about.
These are the more easier types, and hopefully you'll feel that way after I'm done introducing these. Step 1, always look for a common factor in all the terms, just like we said earlier. There isn't anything common in all these. Step 2, with a trinomial, I like to write out off to the side all the factors of the last term. That's what we're looking at, this last number. And here's how we read it. It's the only time I'll tell you this. You read from right to left, and here's how it goes. The factors of 4 that add to give you the middle term 5. So when you look at these two sets of factors over here, clearly only one of them adds to give you 5.
Right. Jerry's given you a list there of the 2 possible pairs of numbers that when you multiply them give you 4, the last number. 1 times 4 is 4, and 2 times 2 is 4. But we're looking for numbers that multiply to 4 and add to 5, and there's only one pair of numbers there that works, 1 and 4.
That's it. Now, from here, put down 2 sets of parentheses. The x square, the factors of x square are only x and x, and they go in the first position of both parentheses. The 1 and 4, you can use any order that you like, 4, 1, or 1 and 4. The bottom line is we are adding to get 5, and we want a positive 5. So if you recall your addition rules, in order to add, signs have to be the same. So if we want a positive 5, that's how we're going to obtain it here.
That's right. And believe it or not, that's the answer.
That is it.
If you understand how to connect the last number to the middle number, these actually can be factored pretty quickly.
Yes. Okay, let's look at the next one. Factors of 30. A little bit bigger of a list. Got 1 and 30, 2 and 15, 3 and 10, and then 5 and 6.
Okay, so this is all of the possible factors of 30. And as Jerry said, we want factors of 30 that add to 11, the middle number. For now, we're not going to worry about the sign of the middle number. We'll worry about that last.
Absolutely. Okay, so the only factors of 30 that do add to give us 11 are the 5 and the 6. So again, we start out, put your x's in here and here. Again, the order of 5 and 6 does not matter. And now our signs, since we're adding to get a negative 11, they both have to be negative. Remember, two negatives added together stays negative. Okay, and that is the final answer on that one.
That's right.
Okay, the last one on this page, factors of 25, just a limited amount, 1 and 25, and 5 and 5. Now again, factors of 25 that add to give us 10. Well, this one's probably easier than the other ones above. We're going to use those two 5s right there because they clearly add together to give us 10. So we plug in our 5s, both positive. Now, Bill, a lot of times that final answer is not appearing in a multiple choice test, is it?
That's right. So in other words, if you're doing this problem longhand, if you write this as your final answer, your teachers will accept it. But if it was a multiple choice question, it probably wouldn't be written that way. Can you think about another way that they might write x plus 5 times x plus 5? Let's give you a little time to think about that.
Well, hopefully, if you said x plus 5 quantity squared, then you were correct.
That's
Good
right.
job.
So to make it clear, either of those answers would be fine if you were doing these problems by hand, but often in multiple choice answers, you won't see x plus 5 times x plus 5. You'll just see x plus 5 squared.
Absolutely.
One other thing to think about before we go on, and maybe it's worth remembering, is that if you're doing problems where the last sign is plus, the signs in the answer will always be the same. Either both signs will be plus or both signs will be minus. That might be worth remembering or maybe writing down on an index card if you're taking notes on these lectures.
Like those index cards.
I always love index cards.
All right. The next one sometimes throws students for a little loop because we have this y squared out here at the end. But
That's right. This one looks harder, but really it's not.
It isn't. We're going to start just like we have before and write out all those factors of 16. So 1 and 16, 2 and 8, 4 and 4. Now, this is our first one where we're actually going to subtract to get our middle term because it says the factors of 16 that subtract to give us 6. So out of our choices, if you are looking at the 2 and the 8, then you are correct.
That's right, those work. When you multiply 8 and 2, you get 16. When you subtract, 8 minus 2 is 6. That's what we're looking for.
That's it. So back to the problem. Now, just as we addressed the x's before, we just wrote them in here and here. We're going to do the exact same thing with our y's. The y's are in the last position, which means they go in the last position in both parentheses. You've covered your x's, you've now covered your y's. Don't worry about them. Now we just put in our numbers. And again, order doesn't matter at this point.
Right, because we're going to go ahead and put the signs in last.
Signs are last.
You could put 2, 8, or you could put 8, 2.
Now, we want a positive 6. So, always put the sign of this number with your larger factor here. So you want...
That's right. 8 is the larger number, so 8 gets that positive sign from the beginning of the problem. Thanks, Jerry.
No problem. And then, of course, the other sign, the negative, goes on the other. And
right. So if the last sign is negative, the signs will always be different. One will be plus and one will be minus. Your job is just to figure out which number gets the plus sign, which number gets the minus sign. You can also think about it this way. You want the term in the middle to be positive 6. To get positive 6, you'd add positive 8 to negative 2.
Okay, on this last problem, writing out the factors of 12, we have 1 and 12, 2 and 6, 3 and 4. And again, we are looking for the factors of 12 that subtract to give us, just picture that as a 1 in the middle. So out of these factors, you will find the 3 and the 4 are the ones that do subtract to give us the 1. Start with our x's. They go in the first position of both, and then the 3 and the 4. And now, again, we want a -1, so put the negative with the bigger number, the positive on the smaller. We're now in that area where many of you decided to drop out of school, would you say? This is where algebra hit the fan, and you decided that it was not right for you. And we're glad you made it back.
That's right. This is something that you may have been taught using a method called trial and error that we'd be willing to bet that if you're taking this class, this is one of the reasons that you're in it. So Jerry and I are going to do our best now to try to show you a little easier way to do these problems so that maybe they won't be quite as stressful as they were a couple years ago.
Absolutely. Let's start with this first one. When you look at this problem, the first thing you'll notice when you look at this problem is this one has coefficients at both ends. Now, going back to Rule 1 that we learned earlier, we want to see if there's anything common in all three of these. And by inspection, we see no, there is nothing in common in all three. So once we notice that, the first thing we want to do is multiply the first and the last term together. This gives us the number 24. Now take 24 and write out all the factors of 24, just like we did in our last lesson when we were looking at just the last term. So we have 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now out of those factors, we're still reading these problems from right to left. It's the factors of 4 and 6 that subtract to give us 5. So when you look at these factors, you'll notice that there is only one, and that would be the 3 and the 8, that subtract to give us 5.
That's right. The 3 multiplied by 8 gives us the 24, and 8 minus 3 is 5. So those are the two numbers we're looking for.
So once you know this, we want to go up and place our signs on these two to create a -5. So we want the 8 to be negative and the 3 to be positive. So -8x plus 3x gives us -5x. Now, we're going to carry down, I'm going to try to do some dots here. You're going to carry down the 6x squared. We're going to substitute these two expressions for our middle expression.
And notice the order here doesn't matter. You could put -8x and then put plus 3x, or you can put the plus 3x first and then the -8x. Your final answer will still be the same.
Okay, so now this new expression, Bill, this is the exact same thing as our first expression, isn't it?
That's right. If you were to add those two middle terms, you would indeed have 6x squared minus 5x minus 4, just what we started with.
That's it. So now what we're going to do is go to our grouping problems that we just did. We want to group the first two and the last two together. And again, reviewing what we just learned in the last lesson, we're going to take out a 3x from these two, and that leaves us with 2x plus 1. And remember, when that third term is negative, you want to take out a negative. So we're going to take out a -4, and that too will give us 2x plus 1. Now, this leads us to our final answer. 2x plus 1, parentheses 3x minus 4. What do you think, Bill?
I think that's right. That's the final answer. Now, the first time we do one of these problems, step by step by step, it may seem like these problems will take a long time, and you may be thinking to yourself, there's no way I'm ever going to be able to factor a problem like that, or there's no way I'm going to be able to factor a problem like that quickly, say you're taking this problem on a quiz or on a test. But I think you'll find after just a little bit of practice, you'll be doing these steps in order without even really thinking about it too much. So I think by the end of this section, you may find that you can do these types of problems pretty quickly, even if it seems to you right now that they're just going to take forever to do. So I guess my advice right now is don't get frustrated. Don't worry if it takes a little while to get used to doing this. I promise it'll click after a while.
Absolutely. Okay, well, let's go ahead and look at the next problem. This problem, we have that situation where you have the y's and the x's, and just remember, we will deal with those at the very end. Right now, we're just going to worry about our numbers and trying to get that middle term of a positive 4. So, step 1 again, multiply the first and the last number, and that gives us 12. Now, writing out all the factors of 12, 1 and 12, 2 and 6, 3 and 4, and then we ask ourselves which set of factors subtract to give us 4. Well, the 2 and the 6 are the ones that are going to work for us in this problem. And then apply the signs. You want a positive 4, so make the biggest one positive and the smallest one negative. And remember, we have two different signs because we are subtracting to get the middle term.
That's right. It's still the case. When your last sign is minus, the signs will be different. When your last sign is plus, the signs will be the same, just as it was in the previous trinomial problems.
Absolutely. So, we're going to carry down that 4x squared, write in our negative 2x and our positive 6x, and now we're going to carry down that negative 3y squared. Now, I just noticed something, Bill. I didn't put the y's on these here in the middle. Not that that means a lot at this point, but for the sake of...
Yeah, it's worth remembering that if the 4 has an xy, then the negative 2 and the 6 will have an xy too. Whatever's in that middle term, just carry it down. If it's an x, carry down an x. If it's a y, carry down a y. If it's an xy, carry down an xy. Just copy whatever you see in that middle term.
Exactly. These two, before you rewrite them down here, you should really double check and make sure that when you combine them, you get the exact middle term. So, from here, we're now going to do our grouping method. Group the first two and the last two together. Out of the first two, we can take out a 2 and an x. And that leaves us with 2x minus y. Out of our last two, we can take out a positive 3y. And again, we should get the exact same parenthesis here. So 2x minus y will go there. And just a mental check, take 3y times 2x, make sure you get this term, then 3y times negative y gives you that term. And then of course your final step, you have 2x minus y in one parenthesis and the other one, 2x plus 3y.
Again, if you have trouble with that last step, just remember the piece that you wrote twice is always the first part of the answer, and those two leftover pieces are the second part of the answer.
Good point. Okay, let's look at one more.
All right, let's go ahead and do an example where the last sign is plus to compare to the problems where the last sign is minus, just to make sure we've done examples of both types of problems.
Okay. This problem, again, you will notice the first term and the last term are both numbers, so multiply those together. Gives you 60. This number has a few more factors than the 12 and the 24. Always start with 1. 1 times 60, then to 2, then to 3. And then we know 4 goes in there 15 times. 5 goes in there 12 times. 6 and 10. And then you think 7, 8, 9. And then once you get to a number that's on the right-hand side, you know you've got them all. Okay, now, again, we're looking for the factors that add to give us 19. So right here, we see the 4 and the 15. And our signs are pretty simple on this one. When you're adding to get the middle, and the middle is positive, you know that the signs both have to be positive.
That's right. The one thing you can always know is if all the signs in the problem are plus, then all the signs in your answer will be plus too. That's one of the nicer problems.
Absolutely. And we're nice people, right, Bill?
That's right. We are nice people, Jerry.
All right, carry down that first term, the 3x squared, and now we're substituting these two terms for our 19. So plus 4x, penmanship is going away, plus 15x, and then we carry down that 20.
Right, and now the worst part of the problem is over. All that's left is just the factoring by grouping.
That's it, and we want to group the first two and the last two together. Out of the first two, we can take out an x and that leaves us with 3x plus 4. Out of the second 2, we can take out a 5. And again, we end up with 3x plus 4. This leads us to our final answer, and I'm going to bring this up because we want to show you a little trick with this. Final answer is 3x plus 4, parentheses, x plus 5.
And let me just say something before Jerry does what he's about to and point out, don't always assume that in that first term there, both a number and a letter will factor out. Sometimes just the letter will factor out. So notice with 3x squared plus 4x, the only thing that's in both places there is the x. So sometimes when you're factoring that first part of the factoring by grouping, there'll be both a number and a letter that factors out, but sometimes just a letter factors out. That's okay. That doesn't mean that you made a mistake. It's just sometimes the problems work that way.
That's right. And if you just remember with grouping method, if these parentheses aren't the same, you've probably done something wrong.
Right. But if those parentheses are the same, chances are you've done it right.
Absolutely. Now, here's a little technique we wanted to show you. This is kind of an application of the FOIL method, and your teachers, when they walk around and in about 2 seconds tell you no, you're right or no, you're wrong, this is what they're actually doing here. What they are taking is the inners, and they're multiplying those and storing those in their head, and the outers and multiplying those and storing those in their head.
Right, and if the 15x and 4x adds to 19x, the middle term, then they know just by looking at it your answer is right. And that's why when we walk around the room and look at your answer, we only have to glance at it for a second or two to be able to say, that one's right or that one's wrong. So this is a relatively quick way to check your answer if you want to do that before you go on to the next problem.
Absolutely. So why don't we move on?
All right, let's go on. Let's talk about problems that are binomials. These are factoring problems that involve only 2 terms. And for this course, we'll mainly be interested in one type of binomial, that's a difference of 2 squares.
Yes, and be thankful for that. Save the next ones for intermediate algebra.
That's right.
Now, the first thing we want you to notice with these problems is the fact that you have a minus sign in the middle, number 1. That implies our difference, where we're coming up with difference of 2 squares. Secondly, perfect squares. At this point, if these numbers don't jump off the page at you, by the end of this chapter, they hopefully will. We have a list of perfect squares, and I'm going to write them across the top. Starts with 1, then 4.
Which is 2 times 2.
Then 9.
3 times 3.
16, 25, 36, and so on. And we don't want you to memorize these. All we want you to know is how we find them, and that's simply just taking 1 and squaring it, 2 and squaring it, and so forth. Hence the term a perfect square.
And when we look at these problems, the thing that leaps out to us as teachers is we look at these problems and immediately see those perfect squares over and over in the problem. There's a 9, there's a 4, there's a 25. If you see those perfect squares, chances are it's a difference of squares problem. That's what you should be looking for in these problems.
Absolutely.
The nice thing is, well, these are really easy to factor, as Jerry will show you.
Yes. The key here is just recognition. Number 1, if you see 2 terms, and you always test Rule 1, if Rule 1 does not work, which is take out something common, when you see 2 terms, first thing you want to do is say, is this a difference of 2 squares? And once you recognize that x is a perfect square because it's squared, 9 is the perfect square of 3, you actually write down the perfect square of x squared, which is x, and then the perfect square of 9, which is 3.
Right, in other words, you just ask yourself, what do I multiply by itself to get x squared? That's x times x. And what do I multiply by itself to get 9? That's 3 times 3. And just put them in the beginning and the end of both parentheses.
And then the ending is put a plus and a minus, or minus and a plus, and you are finished.
That's right. The signs are always opposite, but the order doesn't matter. Your final answer can be x plus 3 times x minus 3, or you can also write it as x minus 3 times x plus 3. Most textbooks, some of them do it in different ways, and your teacher won't care either.
That's right. Now, remember that little check method we just showed you? Notice what happens in the middle. Positive 3x, negative 3x. Notice those cancel out to 0. And that's what happens. To have a binomial expression here, you need the middle term to cancel out the nothing.
That's right. So in all of these difference of square problems, if you were to add the outer terms and the inner terms from your FOIL, you always get 0. And again, that's a good way to check and make sure your answer is correct.
Absolutely. Okay, the next one, again, once you recognize, put down your 2 sets of parentheses. 4x squared is equal to 2x times 2x. 25 is 5 and 5. And then again, just for the sake of it, we'll do plus and minus backwards. And again, you're finished.
That's it. That's all you have to do.
All right, let's look at some more. Now we end up with the XY situation. Again, no sweat off our back. Once we recognize these are all perfect squares, put down your 2 sets of parentheses. This is 4x times 4x. 49y squared is equal to 7y times 7y. And then a plus and a minus, and you have taken care of that problem.
That's it. These are usually popular problems, but these do show up over and over and over, so it's worth remembering these problems. You'll see them a lot in this course and in future courses.
Absolutely.
All right.
Now, here's one that if we gave you about 10 seconds to look at, you would probably go ahead and write down x plus 9y and x plus 9y.
Actually, x plus 9y and x minus 9y.
Some would.
Maybe. Yeah.
Some would. Do you notice there's a difference? This one has the plus, and this is a getcha problem. People call me Trick Daddy sometimes, and this is one of those Trick Daddy kind of questions.
That's right.
I still don't know who he is, but no, anyway. When you look at this problem, you see the plus. As soon as you see the plus, if you cannot apply Rule 1, this problem is not factorable.
That's right. This problem can't be factored. So in a difference of square problems, it has to be a difference. It's got to be subtraction. Most of the time, the textbooks will throw in a problem like this where there's a plus sign. A problem like that, even though x squared is a perfect square and 81y squared is a perfect square, if they're being added, you can't factor it. You can only factor it when they're being subtracted.
Exactly.
All right, so hopefully the fact that we've gone over this will stop you from falling for this if you see it on in a textbook or on a quiz or on a test.
Absolutely.
All right, let's look at what we call our last rule. These are problems that involve more than one step. Up to now, we've done problems that each show you the different individual types of factoring you'll have to do. In these last couple of problems, you may have to use more than one type of factoring.
Absolutely, and we just want you to go through those rules. And let's look at this first one. Your brain should automatically look at a problem and say, is there something common I can take out? When you look at this problem, there is. You'll notice that there is a 5 that divides both of these. So your first step is take a 5 out, and in parentheses, you'll end up with x squared minus 4. Again, why? Because 5 times x squared is 5x squared. 5 times negative 4 is negative 20. Now, you will notice with these problems is this term inside the parentheses is just like the problems we were completing just a little while ago, which are the difference of 2 squares. So you carry down the 5 again, and now you treat that like it's its own problem. Put your x's in, here and here, then your 2, and then a plus and a minus, or a minus and a plus, however you want to do it. And that finishes that problem.
We can't emphasize enough that you need to keep bringing down that 5. A common mistake we see is that students start focusing on factoring x squared minus 4, and they'll get the x plus 2 and x minus 2 correct, but they'll leave the 5 up there in that previous step. So once you've factored something out, you need to keep copying it down. It'll stay there all the way through until your final answer.
Absolutely.
All right.
Okay, this next one, again, Rule 1, if you look really close, you will see that this problem is divisible by 2, each and every term. So our first step is going to be to take a 2 out, leave a little bit more room for the trinomial, and you'll have an x squared plus 2x minus 3. Now, in this trinomial, you look at that last term, you say, okay, what are those factors of 3? Well,
And this is an easy one because there's really only 2 factors of 3, 1 and 3.
that's it. And do those factors subtract to give me 2? The answer is yes. So again, treat it like it's its own problem here. So you put down your 2 sets of parentheses, Put your x here and here. And it doesn't matter the order on the 1 and the 3. All that matters is that you end up with a positive 2 when you're finished. So the plus goes on the 3 and the minus on the 1. And that problem is now finished.
Right, that one's done as well.
Okay?
Finally, let's look at probably the hardest type of problem you might see in this section.
Yeah, sometimes teachers, like Bill and I, like to give you these that look a little bit nastier in the beginning. If you just apply Rule 1, this problem gets a lot nicer quickly.
That's right. So don't be scared necessarily by what a problem looks like in the beginning. Once you've factored out that common factor, what's left over may be relatively easy.
That's it. So in this problem, we look at all the terms, and first of all, we notice there is a 3 that is common in all 3 of them.
Mm-hmm.
Then you look at the x's, and you see, well, I've got an x squared and an x, but no x here.
Mm-hmm.
So ignore that, and then look at your y's. I have a y, and a y, and they're all the same power, so I can definitely take out 3y. So what does this leave us with? Well, in the first term, x squared. Second term, 7x, and the last term, 12.
And again, before we go any further, I would multiply each term through just to make sure that what you have there multiplies to what you started with. The 3y times x squared is 3x squared y. The 3y times 7x is positive 21xy. And finally, the 3y times positive 12 is 36y. Looks good. Looks like everything that you factored out still multiplies through to what you started with.
Absolutely.
All right, so now we look at the problem in parentheses.
Yes, and we're going to look at the factors of 12 and just see, are there factors of 12 that add to give us 7? And when we write out the 3 sets of factors, you will see that the 4 and 3 do add to give us 7. So again, carry down that 3y, write down your 2 sets of parentheses, put in the x's, the 3 and the 4, and since we're adding and our middle term is positive, both signs will be positive.
That's right. Again, anytime all the signs are plus in the problem, all the signs in your answer will be plus. That's one thing you can rely on.
Absolutely. Okay, Bill, let's summarize these factoring rules for everyone so that when you look at a problem, because obviously we mix them up, they mix them up on test, what's the brain supposed to do when they look at it?
Right, what's the order of the questions you ask yourself? When you're looking at a problem, how do you know what to do or which factoring method to use? Let's summarize how you can figure that out.
Absolutely. The first step is always to find, if there is one, a greatest common factor and take it out. So if you do see a common term that is in all the parts of the problem, you want to factor that out first.
Right. Anytime you do that, it'll make the problem easier. So you always want to check for that first. Whatever is left over will be much simpler than the original problem.
Right. Now, when you count the number of terms, Rule 2 is when you see 4 terms, you should immediately think of the grouping method. Group the first 2, the last 2, and then go from there.
That's right. If you have a problem with 4 terms, the only method we've shown you to factor it is the factoring by grouping method. Right. So if you see 4 terms, it has to be that type of problem. Otherwise, you wouldn't know how to do it.
That's right. Rule 3, when you see 3 terms, your trinomials, those are the traditional problems where you normally write down 2 sets of parentheses and go from there. We've shown you the different methods for accomplishing that. You normally always start to write out factors of certain numbers. So just remember, trinomials, 2 sets of parentheses, and get going.
That's right. And those are the problems that I would think traditionally, when you think of factoring, these are the problems that you probably think of that you're most familiar with doing either in high school or in previous math classes.
Right. Rule 4, when you see 2 terms, again, we always start with the first rule, but by the time you get to Rule 4, if there are 2 terms remaining, you're looking for a difference of 2 perfect squares.
That's right. In intermediate algebra, you'll look at some other problems that only have 2 terms. But in this course, that's the only one we're looking at. So if there's only 2 terms, if you see a subtraction sign, chances are it's a difference of squares problem. It's the only problem we can give you.
Now, the last rule that we just covered is you always check to see if it can be factored again.
Right. Sometimes you'll think you're finished, but one of your terms in your final answer, something still can be factored out of that. So it's always worth looking at your final answer and asking yourself, am I done? Have I really factored everything I can? If the answer is yes, then go ahead and go on to the next problem. But if not, go ahead and factor that last little bit and then combine your answer together. Because the directions in these problems will always say factor completely. That means factor until you can't factor anymore. So even if your answer is correct in the sense that if you multiply it together, you'll still get the original problem, if you haven't factored completely, then we still have to take off some partial credit.
That's right.
Does that cover everything, Jerry?
I think we've covered factoring.
All right, that was a really long chapter. We're going to get some fried chicken, and we'll see you back in Chapter 9.